I would be giving a brief about dynamic host configuration protocol. During the course of next few minutes, we would be focusing on why do we need this protocol, what does this protocol do, and any real life use cases of this protocol being implemented. Let's start with why do we need this protocol. So what happens actually is if a big IT network, it says it has thousands of machines which wants to communicate to the internet. So that organization needs to go to an international organization named ICANN and get allocated a block of IP addresses which they can assign to their Linux machines. These block of IP addresses are unique and they could be used as a public IP addresses. Now, there could be thousands of machines. So, in the absence of DHCP, the network admin has to go to log in to each individual machine and has to set up network configuration for each of them. That is a very time consuming process. Like small organization can handle it with hundreds of machines, but big organization with thousands of machines, it's very time consuming. Also, the disadvantage of not having DHCP becomes much more prevalent in wireless networks. Like in wireless networks, a host can go and change its place and join a different network. So each time it changes its network, it has to someone or himself, they need to get a new network configuration and to talk to the internet. Most of the user do not have much info about how to configure network, so DHCP is very helpful in those cases. How DHCP helps is like there is a DHCP server running in the subnet to which clients running DHCP client can connect to the DHCP server and gets network configuration. Network configuration may include the IP address, public IP address, subnet mask, default gateway, which is the first hop router, and the DNS server. Now that we know why we need DHCP, let's talk about how the DHCP protocol works. DHCP is a plug and play client server protocol running in a subnet. By plug and play, I mean a network admin has to set up DHCP server once with the list of IP address it can allocate to the machines in the subnet, and then any new joining host can communicate with the DHCP server and get an IP address in turn. So it's a client server, so client would be running on the host which needs an IP address, and DHCP server is a separate machine which would be listening on port 67 and client would be listening on port 68. So let's look, it's a 4-step process starting with DHCP server discovery, then server offer, then the request, then ACK. Let's look at it and look at these steps in more detail. Let's focus on the diagram. In this case, I've considered there is only one DHCP server in the subnet, but there could be multiple. Let's say this is the new host which wants to configure its network so as to communicate with the internet. What it will do, it will first send a DHCP discover broadcast packet to all the machines in the subnet. Let's look at the internal. It's a UDP packet encapsulated by a IP datagram. Source address would be all zeros because the client doesn't have a source address yet. It's a broadcast packet with all 255, and the port would be 67 because DHCP server is listening on port 67. Type of packet is DHCP discover, and yield address is that since it has not been provided by any address by any DHCP server, the yield address will be all zeros, and transaction ID is just a random number to track responses and request. Like each pair of request and response would have the same transaction ID. Like DHCP discover and DHCP offer are the request and response will have the same transaction ID. So the client sends a DHCP discover a broadcast packet. All the host in the subnet will receive, but only the DHCP server, which is listening on port 68, will accept this packet. Other hosts will discard, and it will send a DHCP offer. DHCP offer is in this packet, it's encapsulated what IP address it can allocate to the host. The source IP address would be the IP address of the DHCP server. It would be a broadcast packet, because this is a broadcast because the host doesn't have an IP address yet. That is one reason to which it want to communicate. Another reason is, in the case of multiple DHCP server offer needs to go to multiple clients, so that the client can make a choice and what IP address it want to choose. Yield address is the address which the DHCP server wants to allocate to the client. Transaction ID would be the same as the previous request. Server ID is to differentiate between different servers. DHCP server, and lifetime is the lease until which the DHCP server won't allocate this IP address to any other host. Once it requests, when the client gets a DHCP offer, in case of multiple DHCP servers, it can get multiple DHCP offer packets. So it chooses one and sends a request and sends a broadcast packet of DHCP request saying that I have accepted this yield address. This is also a broadcast packet because in case of multiple DHCP servers, the other DHCP server whose offer has not been accepted by the client, they need to cancel their yield, so that the IP address become free for being allocated to any other host who wants to join the network. Once a DHCP request is sent to it's a broadcast packet sent to all the hosts in the subnet. The DHCP server which had this server ID will respond back with the DHCP ACK, which will also be a broadcast packet, because we don't know the IP address of the arriving client or the client which needs to join. Once it's done, the communication is over, and once the DHCP ACK is received to the client, here we are seeing only yield address, but the server can provide much more network configuration information like subnet network, subnet gateway, default gateway, subnet mask, default gateway, DNS server. These all information which are useful to configure any network. And once this lease mechanism, it needs to be taken care by the client. So each time the lease is about to expire, the DHCP client will send a lease renewal packet to the DHCP server and will get the lease renewed. Usually the lease time is in days or hours, but here it's kept at short duration. So real life use cases of DHCP is, you can see the home Wi-Fi network. There is a Wi-Fi box, which when you set up a home network, you get a Wi-Fi box which has a internal DHCP server running inside it. So suppose a new guest arrives in your home and they want to connect to the internet. So what they will do, they will open their Wi-Fi. The first step would be to get the network configuration. So if you see in the phone UI, there would be a step like getting IP address. So in that phase, the mobile phone is communicating with the DHCP server inside your Wi-Fi box and trying to get an IP address. And once it gets IP address, then the phone configures the IP address and it's able to communicate to the public internet. It was pretty much about DHCP. Thanks. Have a nice day.